Greetings, fellow mechas. Today, we are looking at the second derivative test, the problem. Use the second derivative test to locate the local extrema for the function f of x equal to 3x to the fourth minus 4x cubed minus 6x squared plus 12x plus 1 on the interval -2 to 2. Now pause this video, take a few minutes, and solve this problem. Welcome back. Hopefully you're able to solve this problem. Now let's work on it together. So we need to use the second derivative test to locate the local extrema for the function. So to do that, we first need to find the first derivative for f prime of x. So f prime of x is going to be equal to 12x cubed minus 12x squared minus 12x plus 12. Now, since we are using the second derivative test, we need to take the second derivative of f of x. So f double prime of x is going to be equal to 36x squared minus 24x minus 12. Now, we can simplify this as this is going to be equal to 12. We can pull out 12 and we get x minus 1 and 3x plus 1. Now, the second derivative test, we need to input our critical points, and our critical points comes from our first f prime of x. So if we simplify our first derivative of f of x, we can pull out 12, and we'll have x plus 1 and x minus 1 squared. So our critical points will be, so critical points are x equal to 1 and x equal to -1. Okay. So now we can implement the second derivative test. So we need to evaluate both our critical points using our second derivative. So let's first use f double prime of -1. And if we input -1 into our second derivative, we will get 1, -1 is 3, -3, -2. And this is plus a -2 is 4. 4 times 12 is 48. So f double prime of -1 is 48, which is greater than 0. Therefore, we have a local minimum at x equal to -1, because that is what the second derivative test states. So if f double prime is greater than 0, we have a local minimum at that x, at our critical point, at that x value. Now let's check our other critical point, which is f double prime of 1. This is going to be equal to, plug in 1, we get 0. So we're going to have 0. So if f double prime is equal to 0, then the test is inconclusive. So therefore, test is inconclusive, which means f may have a local maximum or local minimum or neither at that point, and which in our case is x equal to 1. So that is the solution to this problem. I hope this video helped. If it did, please consider subscribing and liking this video.